Hey everybody, I'm back. This was the the second redox reaction we were going to balance, but my iPad stopped recording, so I'm so sorry. Again, this is off the Chapter 4 unit handout for Chem 111, and we're just going to go through this next lovely practice problem here. I literally just went through the whole thing and none of it recorded, so I'm going to do it again. Bear with me. First thing, assign charges. Okay, oxygen here, well, I'm going to switch colors. Oxygen will be this nice -2 for a total of -8. Potassium will be a +1, which means that manganese is going to be +7 to balance. Hydrogen will be +1, chlorine -1. I come over to KCl, again, based on oxidation charges. I've got +1, -1. Chlorine here, this will be a -1 for a total of -2. And the manganese will counter with its +2 charge. This lovely diatomic chlorine is going to be 0. It's by itself. And then oxygen over here is -2. Each hydrogen is a +1, giving a total of +2. And everything is neutral. So I just want to identify what's being oxidized, what's being reduced, right? So let me see here. What is being reduced? What is gaining electrons? I'm immediately clocking manganese. It goes from this really high positive charge to a +2. I mean, that's pretty average, right? Drama. So it gained literally 5 electrons. That's a ton. And looking for our oxidized species, what was negative and now is less negative? I do clock this chlorine over here, right? I clock this chlorine at a 0, okay? And I do have 1 chlorine, unbalanced of course, on the reactant side. And I know what you're saying, oh, but wait, how do you know that? There's a chlorine in potassium chloride, there's a chlorine in manganese 2 chloride. Like, how do you know? Well, if you look, nothing else is being oxidized, right? So that's how you know. Yeah, so anyway, we're going to have our lovely stuff come down here. I was using purple, right? So for the manganese, this is getting reduced. I'm putting reduced on the bottom. Oxidized on the top, reduced on the bottom. What is getting oxidized? What's getting less negative? Chlorine. I am separating this out. Remember, we have spectator ions. So I'm going to start by saying, hey, chlorine, come here. Chlorine with that -1 charge. And then after that, I come over here and I say, and you're going to pull up right here, Cl2 with a neutral charge. Okay? That's one half of the equation. Let's write the reduced species. It will be Mn and Mn. Now, KMnO4 is the molecule permanganate. Naturally, Mn and O4 do kind of congregate together as a polyatomic ion, right? I know it's not one we regularly learn about, so this would require more chemistry knowledge to know. But when we balance this manganese, oxygen's coming with it. But we can kick out potassium. We don't need potassium. So I got MnO4. This will have a -1 charge overall. And this yields just Mn +2. It's not that attached to chlorine. All right, so let's balance these. Okay, starting with the chloride to diatomic chlorine. I am going to have to add a coefficient. I do have 2 chlorines on this side. I got to have 2 over here. And now I see that on the reactant side, I've got this -2 charge, right? On the product side, it's neutral. So if I want it to balance out on both sides, I've got to add 2 electrons, okay? Amazing. Lovely. Going down to MnO4 on the bottom, the manganese is already balanced. There's just 1 of each. So I'm going to go for the oxygens. I need to balance these 4 oxygens. Well, amazing. I can just add 4 water on the other side, and that'll balance it. Because I added 4 water, and now the oxygens are balanced, it also means I have hydrogens that I have to deal with. So I can balance the 8 hydrogens, right? 8 on the product side, by simply putting 8 on the reactant side. But here's the thing. If I put this large positive charge on the reactant side, I have to also add electrons. The question is, how many, right? So ideally, I'd really like this whole reactant side of the equation to be equal to the charge of my reduced species. So the charge right now, wait, have I been calling it the opposite the whole time? Am I literally tweaking right now? It's not reduced, it's oxidized. These should be the opposite. I'm so sorry. I just went through this, guys. That's my bad. Like a whole 15 minutes explaining it and it didn't record. This is how I know I probably wasn't meant to be a YouTube star. MnO4. Oh no, I was right the first time. Oxidized, reduced. Because I totally forgot that manganese does have that +7 charge, and it's getting reduced to a +2. Okay, that's an important bit of information. I can simply look at that and say, well, let's add up all the charges here. I know the entire MnO4 kind of molecule is -1. I have 8 hydrogen, so it's +8. And I really need that to equal +2. Okay? So, how many negative charges am I adding? Well, I'd say probably 5. This is a +7. If I subtract 5, gives me a +2. 5 electrons. Fantastic. Thanks for listening to my over-explanation. And we'll just get rid of this. So, next step would be, well, my electrons have to be equal. Okay? I'm going to use that lowest common multiple theory. Lowest common multiple of 2 and 5, right? 10. So, I'm going to step in. I'm going to multiply this top equation by 5 to get 10 electrons. Multiply the bottom one by 2 to also get 10 electrons. Okay? Smooth. And I'm just going to write the balanced equations out below. And I'm going to combine everything at once. So I'm going to add all the reactants together on one side, all the products, with their correct coefficients. Starting with chlorine, I now have 10 chloride ions. Oh, I'm using blue again. I know it doesn't matter, but whatever. 10 chloride ions. I also have 2 MnO4 minus. I have 16 hydrogen. And I have 10 electrons. Nice. All right. On the product side, I have 5 chlorines. Technically 10, but 5 diatomic chlorines. I've got 2 Mn2 plus. I've got, so what is it, 8 H2O. And I've got 10 electrons. So, first thing, you know, always cancel the electrons. We don't need them. Irrelevant. And the second thing we're going to do is start adding back in these spectator ions, right? So I do have a couple to put back in, and I've just got to analyze what goes where. So I know on the reactant side, I'm trying to make permanganate and hydrochloric acid. I do have that base for permanganate here. So I'm going to say I have 2 K, potassium is a spectator ion, bring it back in, 2 KMnO4, plus I know I'm going to make HCl, right? HCl, and that's going to come from my hydrogen and my chlorine on the reactant side. I just don't know exactly how much because they have different coefficients. So we're going to hold off. On the product side, I know I have KCl. We actually didn't touch that at all. It is a pure spectator ion. Right here, right? So KCl is coming back in. And then I know I need manganese 2 chloride. That is coming from, oops, I should do it in pink. That's coming from the manganese and from a spectator ion chlorine. So I'm going to go ahead and I'm going to plop that 2 in there, 2 Mn, and then spectator ions Cl2. Cool. Amazing. Then my water stays the same, so I had water in the original equation, so 8H2O. And then I also discovered that I have 5Cl2, right? So I have the coefficient for it now, so that's going on the end, 5Cl2. So I've got a really solid equation. Everything's added back in, everything's canceled. And now I just got to look and I got to ask myself, is everything balanced? That's always what I'm looking for, right? I'm going to look at the hydrogen, and I'm just taking a gander here on the product side. I do have 16 hydrogen, so my best guess right now is that 16 is going to go here. But I do want to look around, and I want to make sure that I've actually got the correct amounts of everything, right? So one thing is my spectator ions are not correctly balancing at the moment. I have this potassium over here, and I got 2 of them, but I only got 1 here. So I am going to plop a 2 down out in front of this. We'll do it in pink. And then I just want to kind of re-add a few things to make sure it all makes sense. So I'm going to look here at the chlorine. Here I've got 10 chlorine. Here I've got 4. Here I've got 2. That all adds up to, what is it? 16. Hooray. And that makes sense because I put a 16 over here with this chlorine. So I know this is very messy and I'm sorry it cut off in the first video, but this is how you would balance this redox reaction. And if you can do these, I absolutely promise you can do anything. Okay. Let me know if there are any questions via email, and I hope you had a good time watching. Redox reactions, guys, they can be fun. They can be. I swear. You just gotta get into them. All right. On to the next. Good luck studying.